COBOLedu is a RAG system that lets you ask natural language questions about the GNU COBOL compiler, a legacy codebase written in C with embedded COBOL test programs. You type a question, it searches roughly 4,000 code chunks, and it returns an answer citing specific files and line numbers. As of Tuesday evening, we had a working MVP deployed on Railray. Basic front end, basic search, you could ask a question and get an answer. But the retrieval quality was honestly not great. And to be honest, I didn't set up observability with LangFuse yet, nor had eval tests set up. So I was essentially flying. Nonetheless, I could tell that the project was flowing around 50% precision at 5 responses, meaning roughly half the time the top results weren't from the files you'd actually expect. So the last 12 hours have been going from it works to it works very well. And here's what that looked like. From the first intervention, it was over-retrieve and re-rank. Instead of asking Pinecone for 5 results, we asked for 20, then used Voyage cross-encoder re-ranker to rescore them down to the best 5. That alone bumped us from 54% to about 59%. Second intervention, query expansion. Dense embeddings are great for semantic similarity, but if you ask about file I/O, the embedding doesn't naturally land near code containing read, write, and open. I added 19 regex-based expansion patterns that bridge that gap. That pushed us up to 74%, but then I added metadata filtering and it actually regressed us back to 66%. Turns out that overexpanding adds noise, but the eval pipeline caught that immediately. As for the third intervention, it was the COBOL identifier decomposition. This was a late addition with outsized impact. COBOL uses hyphenated names like customer record. The embedding model doesn't know that customer record relates to customer and record separately. Decomposing those pushed us to our final number, 71% precision at 5 results, with 94% term coverage. And I did this across 9 named experiment runs in LangFuse, each measuring the delta of a single chain. Beyond retrieval quality, we added streaming answers via SSE, the answer types in token by token instead of blocking. We added 5 special feature tabs: explain, dependency, pattern detection, doc generation, and business logic extraction, plus syntax highlighting with prism.js and file drill down to see surrounding context and copy buttons throughout. Three quick takeaways. What worked well was syntax-aware chunking is a non-negotiable for code RAG. Splitting on function and paragraph boundaries instead of fixed character counts is the foundation everything else is built on. And building the eval pipeline early made every optimization decision data-driven instead of guesswork. What surprised me was that file diversity enforcement mattered more than expected. One large file, cogen.c, was consuming all 5 result slots until we capped it at 3 chunks per file. And the BM25 hybrid search we planned turned out to be unnecessary. The combination of re-ranking and query expansion was enough. But what would I do differently? I definitely would build the observability layer and eval pipeline before the first retrieval experiment and not after. To be honest, we flew blind for the first few phases. Total API cost for the entire development cycle was about $6. The system runs at roughly 1.7 cents per query. The full build guide, architecture docs, and cost analysis are all in the repo. Thanks for watching.